Hello everyone, thank you for joining us today. We've got a really exciting lesson for you, and it's all about the basics of error handling in Rust. So I think it's important that before we start the lesson is to go over how useful the Rust compiler is by itself. As an example here, if we have an integer and we're trying to increment this integer and you're trying to compile this program, the Rust compiler will quickly flag this for you as an error, but more importantly, it will give you hints as to how you can solve this. Of course, there's a short message once the error is displayed on your screen. However, there is an additional option called explain that gives you additional details as to the nature of that error. So in the case of this integer that we're trying to increment, it will explain to you that by default integers are non-mutable and you can't just increment them. The same thing applies to more complex variables. Let's say a string that you've assigned an initial value and then you're trying to move it later. If you issue an explain command, as you can see the error that we've had here, it will explain to you in detail what happened and how you can prevent this. There is another option here that comes in extremely handy when you're trying to debug a program. Now, let's say you're dealing with complex code with multiple libraries and multiple files, but you're seeing an error and you're not sure of the origin of that error. If you turn on something called the Backtrace environment variable in the cargo run command, you should be able to see the full list of the different functions that led to that error. And the way to do that, once you see the output, you read it from the top to the bottom. So the top is essentially the origin, and that might include the default libraries that come with the Rust and what they call the prelude, all the way to where the error is in your program. And I think this is a good example that highlights how this actually works. Now, to enable this, as I mentioned, it's just a simple environment variable. So on Windows, you enable it this way. On Linux and Mac, you use the export command, or you just put it all in line, like this example here. Now, the next bit we're going to look at is how to handle unrecoverable errors in Rust. Lucky for us, Rust does provide us with a convenient macro called panic. You can use the panic macro to quit the program execution. But what happens when the panic macro itself executes? Well, first the message, if you included one in the panic macro, will be printed on your screen. Then the program unwinds and cleans up the stack, and then it quits. This is of course very expensive, and it will make your final binary a little bit bigger than it should. However, there is a way to disable this functionality by making macro essentially aborts all of that and leave the cleaning to the operating system itself. This will make your binary much smaller and more compact. Now, let's take a look at an example of how to use panic. Well, as I mentioned earlier, you can use it by itself or by including a message. You can also use it by trying to debug your struct. And this is a good example of how to debug struct using panic. You can just issue the curly braces, colon, question mark, and that will print out the fields for your structs. So in my case, I have a struct called car here that I created at line 2, and I am printing it at line 9. So what we've seen so far is the explicit use of the panic macro, but there are other situations where your program will panic, such as division by 0, or even external factors such as your operating system running out of RAM, or the network gets disconnected in the middle of the execution of a certain network functionality, for example. Now, the other two macros that I want to talk about here, and they are very closely related to panic since they both panic the program, is called unimplemented and unreachable. Now, these are self-explanatory. So if you look at the first one, for example, you use unimplemented if you have some code section within your library, if you're writing one, that are not completed yet. So for example, you may have a function that says v2 and it's just a placeholder. You can include the unimplemented macro in there. Now the unreachable macro also panics the program, and that basically just defines a certain path that the program should not enter. And this is usually if you're using if else or some sort of match statement, you'll add unreachable in there. And we can of course set custom messages on these macros if you want to give a more meaningful error message to the user. The next two macros I want to look at here is assertions. There is quite a few assertion macros in Rust, but I'm only going to cover assert and assert underscore equals. Now, as you can see here at line 4, it's pretty straightforward to issue assert. It will check whether the expression is true. And of course, it panics if the expression itself is false, as you can see here. Now, the second macro I want to look at is assertion equal. So instead of trying to do Boolean expression within the assert macro, you can have two fields with assert underscore equal, and here it will ensure that the two expressions are equal. It panics if the expressions are not equal. What's more important here is that you can actually add debugging information, so you can add a message to assert underscore equal if you wanted to debug some information. Okay, I think we've just about covered the basics here. In the next lesson, we'll try and cover more advanced error handling topics. All right, thank you so much, and I'll see you in the next lesson.